All right. All right. Hi. Hello. Good morning. Thank you for having me. So nice to see so many familiar faces in the audience. I'm very happy to and glad to be here. And I'm going to rush through because time is of essence. And so we're going to talk about scaling machine learning or AI models in Kubernetes, right? So be prepared to be amazed or to learn a few things that I learned myself and for a small demo. So I'm Alessandro. I'm Italian, as you can tell from my accent. I've been living in Amsterdam for 20 years, so I know a few things about living in the Netherlands. And one of the things I'm quite proud of, started the Dutch Kubernetes meetup more than 8 years ago. Kubernetes is 10 years old, so it was pretty much at the beginning. It's a very vibrant, very active community. It's 4,000 members few weeks ago, so I think it's growing now. I'm a CNCF ambassador, so it's an honorary title. I don't get paid for it, but I just like to talk about whatever goes on in the Cloud Native Computing Foundation. I'm also involved in the environmental sustainability efforts of CNCF. I'm a Kube astronaut. I like to take certification, so I have 10 certifications. I'm going for the final one to become a golden Kube astronaut. And I used to work at Microsoft for a long time, most of my career. I quit 2 years ago, and I'm back as January. So I talk about stuff that I really love, and I work with amazing people and with amazing technology, also in open source. Open source is the modus operandi of Microsoft as of a few years. I do a few other things, of course, like I have my own startup. That's why maybe you've seen Kube Spaces and other things. But yeah, as of now, I'm fully focused on cloud native in Azure, and especially running AI machine learning workloads in AKS, in Kubernetes. So we live in extraordinary times. I'm blessed because I saw the rise of the internet. I remember my first phone, mobile phone, my first mobile smartphone, and now we are witnessing these crazy times where you can just ask a model to code for you and to tell you what is the best diet and what to do with your life. It's really mind-blowing, and I'm every day amazed by what we can do. So there are so many, and it's really recent, like the paper about GPTs, the transform is from 2021, which is really not that long ago, and see how fast it goes. Just every week almost, there is a new model announced. This was 2022, right? So I remember that, of course, like people were shocked by that. You could talk to a machine and it gives you some almost reasonable answers. And then there was more and more models presented. Now we are GPT 4.5 was announced yesterday, literally yesterday. Sonnet 3.7 also last week. Microsoft 5.4 also last week. It's very, very fast. So you have to. I check the news every day. What's new on the market? What can I do more than yesterday? So it's crazy. And how do you do that? I mean, how this works? So LLMs are everywhere. We love them. We need them. Our businesses needs it. So it's not only a personal interest, but also an enterprise interest. So that comes with problems, of course. Is the cost of AI that we really need to take care of. And it's not just a cost in terms of, OK, you can think of jobs, sure. Maybe they're going to take some jobs, but maybe they're going to create even more jobs that they create. But most important is that we need to understand the impact of what we do. We don't work and live in a vacuum. Our choices matters. How we run these models matters, especially how we run it, where we run it, how scalable, how sustainable is running models at scale. So this is interesting. It's I know it's just a number, it doesn't mean a lot, but there was a scientific research explaining that a prompt in ChatGPT, I think it was 3 points, ChatGPT 2 or 3, generate or consumes 5 liters of water, right? So because these servers, they do inference, they need to be cooled. All the energy and water needed to train and cool, to cool the servers that do the training beforehand. So it's not just the prompt, but it's also what comes before, right? So, and of course, with the rise of new models, small language models, and things like DeepSeek, they demonstrate that you can actually train with less, you can do inference with less, and you should do it because that means it's better for the planet. And eventually, we only have one planet, and we need to take care of it, right? So why is hard to deploy LLMs? Well, of course, you need a lot of computing power. You need to scale GPU's usage. Latency in inference do matters. Few milliseconds in the latency of the prompt response, it is a big deal, and people stare at the screen even for a few milliseconds means that they are not, the fluency and the flow, it's kind of disrupted. And that's okay for text application, for chats, but if you think of real-time AI, like voice application and video application, that really matters. So it's hard. Let's see if we have something that can help us. Of course, this is how it works, right? So you think ML or data scientist role is just everything. In fact, what you need is MLOps, right? So it's the operation, the operations around running LLMs that really matters. So this talk is about what do we do. Somebody's preparing the LLMs for us. There are thousands of models as of now. Go to Hugging Face. There's tons of models readily available, so already trained. How do we run them? So this talk is about where do we run them? Where? Kubernetes to the rescue, of course. I'm biased. I'm a CNCF ambassador, as I said. Kubernetes is a 10-year-old project. Who doesn't know Kubernetes? Or who knows Kubernetes? All right, okay, see. We did a good job for the last 10 years to make it better, of course. Make it better also means there's a whole community of developers, practitioners, users, community people like us that work to make this project the best scheduler for workloads, any workloads, stateless, stateful, and finally also machine learning workloads and LLMs. So what can Kubernetes bring to the table? You can scale, you can schedule, it helps you retrieve the resources that you need when you need them and tear it down when you don't. So it's this self-healing machine that manages other machines and can manage your workloads running properly and right size, we say. Right? So, okay, so that's fantastic. We need Kubernetes, of course. What is the community doing about it, right? So within the Cloud Native Computing Foundation, there is a lot of people really thinking about this. Of course, this has been going on for a couple of years now. Within the big Cloud Native Computing Foundation, there are these technical advisory groups. You can join them. They are open micro communities within the larger community. One is the Cloud Native Tag runtime. It thinks about all sorts of different runtimes that you can have within Kubernetes. One of this working group within this tag is the Cloud Native AI working group. You can tell from the examples, ChatGPT itself is being trained on large-scale Kubernetes clusters, AKS, by the way, and many more models are trained on Kubernetes. So it produced things like the artificial intelligence white paper, goes all over what you need to run when you want to run cloud-native AI workloads. This is from that white paper. So you need several layers, right? From the cloud provider to the GPUs to something that manages the life cycle. So the tool we're going to talk about today, and there are many tools out there. Of course, these are all part of CNCF. So they are projects that have been donated to the Cloud Native Computing Foundation, like Q with the KU, blah, blah, is a new project as well. K8s GPT helps you troubleshoot your clusters through AI, through models. Most famous is Kubeflow, which is a whole suite of tools together that together can provide you a platform to operate large-scale AI projects. So it goes from training, inference, parameterization, serving all those models. So the tool we're going to talk about, and let's open a parenthesis, of course. So another tag also interested in AI workloads is the tag that I'm the humble tech lead, and Vilko, of course, is also member of the tag. We talk about sustainability of software, specifically the cloud-native software. So we also provide tools, or we take care of these tools like Kepler and Kate from our friends at Agnostic that measure emission and consumption of cloud-native workloads. So that's very important for us, and it all comes together when I talk about. So we want to run AI machine learning workloads. Where do we run them? In Kubernetes? Great, but can we also measure and tame the complexity, but also the emission and the impact that the software has? So yes, we do CSF tag environmental sustainability. It's again like an open group, open forum. We can talk about as much as you like. I got 8 minutes left, so there is a tool that was released not even a year ago by Microsoft open source team called Kaito, Kubernetes AI Toolchain Operator. It's one of the many, right? So there's not, as I said, there's Kubeflow. You can do this in Kubeflow. You can do this. NVIDIA has its own tool. I think it's called NIM. But this is, and it's not specific to AKS or to any managed Kubernetes cluster. You can use it anywhere. And it's a tool to reduce the complexity of running and addressing the challenges of running AI machine learning models in Kubernetes. So instead of the many steps you need to download, containerize, and run these workloads and monitor and scale them, we leverage the power of controllers to run these workloads in Kubernetes. So you can do deployment, inference, and iterate over these models using Kaito. It's just one example, but it's what I think I find it pretty compelling to use, right? So instead of going through manual steps of provisioning GPU nodes and do all sorts of magic stuff, Kaito, because it's an operator that has all the logic within the operator itself, I can do anything. I can do everything in one go without with just one object, which is the workspace, right? So the workspace is the core of Kaito. Describes everything about the workload you want to run, and the most powerful feature is that the development team, the team behind Kaito, prepares presets, right? So you don't need to really understand much about it. You don't need to know exactly what model fits into which GPU virtual machine size. This is all done through presets. And you can make your own, of course. You can you can add more models and more presets to the project, but it's how it works. You create one object, the workspace, with everything in there, everything needed, and the controller sits that you install in your Kubernetes cluster will do the rest. Will provision the node, by the way, it's going to use a project called Carpenter, also very popular, to provision exactly the capacity that you need for that workload. No more, no less, just exactly what VM size fits your model and your presets. So it's a way to distribute and deploy and manage AI workloads in Kubernetes. So it's agnostic, as in it runs in any cluster, anywhere you have a Kubernetes cluster. So what is an operator, by the way? So our operator is logic embedded, and this from a friend of mine. The link is there. So you embed the logic in a controller, and you create these CRDs, the custom resource definitions, that describe what you want to do. So a controller in Kubernetes is a routine, is usually written in Golang, and it watches over new objects or objects that are being modified and operates on those objects, right? So as in here, so anytime you update or modify or create a new workspace, the controller will update and constantly reconcile the desired state with the actual state with the desired state of what you want to do. So a note on Carpenter, very popular provision or scheduler, so to say, scheduler and provisioner of resources in Kubernetes. Started in AWS, and now, of course, there is also available in Azure. What is the difference of Carpenter versus regular cluster node autoscaler? Is that the cluster node autoscaler it's not really smart, right? So it just scales an existing node pool up, right? So scales horizontally a node pool that's already been defined. So it cannot make a decision based on the type of pod that you want to schedule about which size the new node is gonna be. But Carpenter has a bunch of concepts like node claims and machine classes that can fit what you need with what is there. So you go from like several steps, several manual steps into I have a cluster, I deploy Kaito, bam, I create a workspace, and here it goes. And that's how the workspace object look like. You can define the instance type. So this is, of course, specific to the cloud provider you use, because as we're going to demonstrate, I have a short time for a demo. The instance type is specific to the cloud provider. So in Azure, they're called standard NC something something. So you can override or you can rely on the preset standard, the preset predefined machine size. So the machine size is what we're going to create for this model, but also there's a default for the model. And this where, so by just specifying the preset name, everything else goes from there, right? So, and it works by, of course, like you add the CRDs, you have a workspace controller because it watches over the controller objects, and it's going to restart in a second. And then when a new workspace is created, the GPU provisioner, which is really the Carpenter side of things, provision a GPU node just of the size. And then the pod that contains the LLM, or SLM, lands on that node, because in virtue of the selectors and the labels on the new node, of course. That's it. So you can also, and of course, like you can pull these images from a private registry or a public registry. So demo. Wish me luck, because I know that it doesn't work. Let me see. Kind of. Okay, so I already created everything myself, so don't worry about it. I'm going to share the GitHub repo for that does this. So it's quite a thing. Still, you know, it's a last version was 0.3, so it's not exactly production ready. It's not something you want to do in production, but it's something you can try out yourself. If you have Azure subscription, like I do, and you also have to, and this is why the demo will fail. So in Azure, of course, like by default, new subscriptions gets 0 quotas for these large, very expensive VM sizes with GPUs. So you need to be careful. You need to request the quota beforehand. I did for different kind of VMs, but I don't have the quota that fits the DeepSeek. I wanted to demonstrate the new DeepSeek, but I kind of failed to request the quota in time, and so it's not going to work. But I'll demonstrate just how it's supposed to work. So you create a group, you create a container registry, so you can push, and this is important, this is very cool. You can use a private container registry to clone a remote registry. So this Microsoft offers a public registry for Docker images, and this Docker image contains the model, the DeepSeek R1 14 billion parameters model, but I don't want to pull it all the time from MCR. I want to store it very close to my cluster in a private registry. So the Azure Container Registry supports this import command that will just clone it from there. And then you create a cluster, already did, and you have to do some magic with service principals and identity, federated identity, because this GPU provisioner needs to create resources, so it needs to have the authority and the credential to do it. You do it through something we call federated identity or federated credential. You deploy the controller via Helm. You deploy the GPU provisioner via Helm, and then, of course, everything is fine. Everything's all right. So you can tell from the Kaito workspace, there's a controller, right? And there is and then the GPU provisioner is also deployed, is running, is fine. And then you create this, and I can do it like this, of course. You create this workspace, right? So, and this is with the Phi 3.5, again, like it's an open source model from Microsoft called Phi. There's different generation, Phi 2, 3, and they just released the Phi 4. And this will just, by creating one object, it creates multiple objects. The controller knows what to do with it, and I'm going to stop right now before it fails, because I know if it's going to fail. So the object creates a node claim, and the node claim, and you can tell from the logs of the GPU provisioner, that is actually starting to provision a new virtual machine. So you can tell, because it's a VM scale set, and you can go to Azure, and you go into the resource group where all the resources of the cluster lives. And this, you see, it's a new VM scale set with the NVIDIA GPU-enabled VMs. And that's it. So it's going to fail, and I know that it's going to fail because I don't have enough quota of this particular VM size. And also I'm running out of time, so just fine. So that's it. I would like to thank you for your time. And of course, if you want to know more, please reach out to me. Join the cloud native sustainability efforts, because there's only one planet and we are running out of resources. So thank you very much.